Welcome to another episode of the Practical SQL Server HA show. My name is Edwin Sarmiento and welcome to this show. If you're joining in for the very first time, the purpose of this show is twofold. One, if you're a technical operator, meaning you're a systems administrator, a database administrator, systems engineer, or you just happen to be the poor developer who knows a little bit about SQL Server and now you're being told to take care of the databases, I really do feel bad for those developers because I used to be that guy writing code and then all of a sudden I was given the responsibility to take care of the databases. But it's a growth opportunity, by the way. It is a growth opportunity if you embrace the suck. If you're a technical operator and you're either in the stage of designing for a SQL Server high availability and or disaster recovery solution, or maybe you already have something in production and you're struggling to keep the lights on, maintain the infrastructure up and running, prevent outages from happening, or an outage just happened and you don't know what to do, right? This is for you, where I share lessons learned mostly from my personal experiences and mistakes that I made, so you don't have to make them yourself. And most of those also from my customers' environments, the projects that I've worked on in the past, and also share some best practices, and not just generic best practices, but best practices where you can filter them out through the lenses of your own environment and asking the question, does this apply to me? Would this make sense in our environment, right? And most of the lessons that I'm sharing with you go beyond just the technical aspect of a SQL Server high availability and disaster recovery solution, because we're so focused as technical professionals, we're so focused on the technical implementation that we forget technology is here to support the business, meaning to solve business problems, to address business needs, and help the business grow, right? I did say two parts, twofold. The first one is for technical operators. The second one is for managers, decision makers, team leads, IT directors, where you're making that conscious choice. Is this the right solution for us? Or if you're managing a team, is my team ready to even support this when we cut over to production? Okay. Today's episode focuses on SQL Server always on availability groups, where because we have been sold a really good product, and I go back to the days when Microsoft introduced this more than a decade ago, where the phrase always on has been tagged on to the feature set. That's also one of the reasons why a lot of people call it always on, not realizing that always on is kind of like an umbrella term for both availability groups and failover clustered instances. But unfortunately, though, people would call it always on because they think that's the availability group feature. And then they kind of have a misconception because, I mean, just think about it for a second. Always on. What does that make you think? It makes you think that this system never is always, right? Always the opposite of always is never. When you hear the word or phrase always on, you kind of think, oh, it never goes offline. It never experiences outages. That's what it is, right? Then Microsoft did a really good job of communicating that to a point where now every deployment is, let's do always on, let's do always on. Not realizing that always on, again, is a marketing umbrella, and you still have to pick and choose between, are we implementing availability groups or failover clustered instances? But the proof of how Microsoft did a really good job with the marketing and the messaging around this feature set has made it so that this is the go-to solution for any new SQL Server high availability and or disaster recovery implementation. It's always this until they look at the different capabilities, limitations, and then they realize, oh, maybe we should go with failover clustered instances. But I wanted to talk about what I call the hidden dangers of SQL Server always on availability groups. I would just say it straight. one of the reasons I like my freedom of not working for any vendor or Microsoft, that is I can share stories from the field, direct experiences from customers, their frustrations, their challenges, and call it as it is. And that's also one of the reasons why I like looking at it more from a practical and pragmatic approach, because the reality is it's not perfect. It is not perfect. But when somebody already made that decision to say, hey, let's implement this, because they have a different way of looking at the feature set, you're stuck there thinking, okay, so we implement this as a technical operator. We're stuck. We're going to implement this regardless. And you have to be clear and be aware of these hidden dangers, okay? Make sure you have your pen and paper ready. Start taking notes. Let's have a look at the different hidden dangers that when I was starting out with this feature, these were the hidden dangers that I never thought I was blindsided by. So first hidden danger is this false sense of security. Okay, false sense of security. What do I mean by this? When you read the Microsoft documentation, it outlines always on availability group is a high availability and or disaster recovery solution. It could be HA, it could be DR, it could be both. Well and good. Until, of course, you realize that just because a feature is classified or described as both a high availability and disaster recovery feature doesn't mean it's going to solve your own disaster recovery requirements. In the earlier years of me working with always on availability groups, I've met so many customers where this was a common design pattern back in the days. 3 replica always on availability groups, 2 nodes or 2 replicas in the production data center, 1 replica in the DR data center, so they're covered technically for both HA and DR. Not something that I would recommend today, okay, because the technology has evolved, there are additional feature sets. But that was a common thing, and I still see that in the field, where you have 2 replicas, both are in a production data center, taking over high availability requirements or providing high availability, and then you have a 3rd replica in the DR and providing DR. Now you might be wondering, what do you mean by false sense of security? I got everything covered. I got multiple copies of my databases, 2 copies in production, 1 copy in DR. I'm all set, right? Until you realize, well, where's your backups? Just because you have a solution that provides both HA and DR doesn't mean you ignore backups. You still need backups. In fact, this is the kind of like the starting point. You always have to have backups. And again, I couldn't count the number of times where a customer would deploy an always on availability groups. HA is covered, DR is covered, but they don't have backups. So what happens when there's a database corruption? Oh yeah, we're covered. We got automatic page repair, and that's what the Microsoft documentation said. Okay, sure. You got automatic page repair. You're covered. But what happens if somebody accidentally dropped a table or truncated a table? That's a disaster. That's a user-induced disaster. Are you covered by that? Because the way availability groups work is it replicates everything. So you may have, in that particular design pattern where you have 3 replicas, you would have 3 copies of your databases, but unfortunately though, those copies look exactly like what you have in production. So if you have an availability group, you've deployed it, and then a user or developer, or sometimes a DBA, so I've done my fair share of running a delete statement without a where clause, and they deleted the entire table. That transaction gets replicated across all replicas. Next thing you know, in a split second, all your databases look exactly the same, meaning all those databases have also had that table either truncated or records deleted. There's no amount of having replicas will save you from that kind of issue. Okay? There's no amount, again, of replication, data replication between those your replicas that would save you from that kind of user-induced disaster. Okay? So just because you have an availability group doesn't mean your backups get neglected. In fact, that's the starting point. You can ignore availability groups. You need to have backups, but not the other way around. Okay? You have to have backups. And then think about having availability groups as part of your overall HA and DR strategy. And again, because I don't want you to start thinking about, hey, the Microsoft documentation says I'm covered as far as DR. Oh, their definition of disaster is different from your definition of disaster. And you have to really think about what the different disasters are. User-induced, human-induced, machine-induced. And this is also another thing to consider, other than making sure that you have backups. Your databases are sitting on a storage subsystem, whether that's a storage area network, a powerful multi-tier storage infrastructure. Sure, but what happens if that storage infrastructure all of a sudden dies? Yeah, but we have RAID and we are properly covered. Sure, but how soon can you fix that if you don't have backups? Well, we'll fail over to our secondary replica. But then your secondary replica is sitting on the exact same storage infrastructure. Again, I'm laughing because I've seen it so many times where I'll go beyond the always-on available groups. These are virtual machines sitting on the same physical host. Same physical host. Okay? They did not configure anti-affinity. So the VMs are sitting on the same physical host. They thought they're highly available. So what happens if that physical host dies? Then both of your VMs die with it. Depending on how you configured your hypervisor, the way it moves the VMs might be totally different from how you expect it to work. Okay? What else? Oh, those VMs are sitting on the same storage infrastructure, same storage subsystem. The entire storage infrastructure dies. Good luck. Okay? So you have to really be clear about this. Just because you have an availability group where you got, again, that design pattern, 2 replicas in production and 1 replica in DR, it kind of makes you think that I'm fully covered, when in reality, you're not. So you have to think of all of these possibilities, and I know it's very impossible unless you've experienced it firsthand. And the only reason I can think about this is I've seen cases where physical machines, 2 different physical machines, 2 different storage subsystems, they're plugged into the same network switch and the same power distribution unit, and then all of a sudden both die at the same time. Stroke of luck, the perfect storm happened. It could happen. So you might as well prepare for it. Okay? Just because the Microsoft documentation said you're covered for both HA and DR doesn't mean it covers you based on your definition of disaster. Okay? So think about that for a second. Again, there's really no substitute to having backups and making sure that you don't configure, or there's no single point of failure is what I'm trying to say. Okay? There's no single point of failure. I've seen cases where the VMs, they've spin up VMs, installed SQL Server, configured always on available groups, but everything sits on one physical host. That physical host becomes the single point of failure. But as DBAs, especially in large organizations, you don't get to see what's happening underneath. And so what ends up happening is you think, hey, I'm highly available until the VM admins decide we're performing maintenance, not realizing you're hosting a high availability solution on the VM sitting on that node, and then they perform maintenance. Next thing you know, your entire cluster goes offline, your databases become unavailable, and then you start mocking always on and start calling it almost on, or sometimes on. Okay, so that's the first hidden danger, that false sense of security. You make sure that there is no single point of failure, and you're looking at it from the top down, all the way to the power distribution unit, networking, storage, everything. Even if it's not your responsibility, make sure that you're communicating that with the teams responsible for making sure that there is no single point of failure. And you're also covered from user issues. As if we don't make mistakes, right? We're humans. We make mistakes. The second one is network latency and misconfiguration. This is a hidden danger because, for one, the fact that SQL Server always on available groups sit on top of a Windows Server failover cluster when your goal is high availability, you're looking at an infrastructure that relies so much on networking. Okay? So it's not just enough for you to understand, hey, this is how the infrastructure works, this is how the platform works, meaning Windows Server failover cluster, and how it interacts with the other nodes to keep the platform highly available. It's also important for you to let the other teams responsible for networking to know exactly what is going on. What do I mean by that? In most of the outages that I've seen, working with always-on availability groups with Windows Server failover clustering, is that an outage typically is a result of some network issue. Typically, network issue. And this reminds me of one of the very first projects I worked on back in 2013. Built a 2-node Windows Server failover cluster with a 2-replica AG, file share witness. And as I was handing off the environment to the customer, I noticed that the Windows event log is starting to fill up with error messages and events telling me that the file share witness is a little bit flaky. File share witness is simply an SMB share on a machine across the network where 2 nodes can access that file share. So the mere fact that the 2 nodes need to have access to the file share means they're dependent. Both of these are dependent on the network, other than the fact that the nodes also need to talk to each other. So it's a networking thing. I told the customer, look, I'm starting to see that there's all of these Windows events telling me that there's something wrong with your file share witness. Go ahead and fix it. They said it's fine. We'll figure it out. And then a couple of weeks later, I get a call telling me that the entire availability group, and by the way, the availability group is used by their internal portal. The entire farm went offline. And when they were, I asked them to describe exactly what went wrong. Patch Tuesdays, they installed security updates on the secondary replica, because that's what the best practice recommendation is. You do the patches, you install updates on the secondary. You can reboot it without having to worry about the primary, because that's what the cluster is about, right? The minute that they rebooted the secondary, the entire farm went offline. And I knew exactly why. Okay? They were not happy with my explanation in the way I described what the problem was. Okay? Their entire farm, meaning their internal portal, went down because the portal depended on the databases. And here's the thing. I mentioned about the file share witness having some networking issues. You have 3 voting members, 2 nodes in a file share witness. That's 3 voting members. The file share witness is flaky, so you're technically down to 2 out of 3 voting members. 2 out of 3. You still have majority. Them rebooting the secondary, the cluster is now down to 1 out of 3 voting members. The cluster, not having quorum, does not have any other choice but to take itself offline as a self-preservation mechanism. I told them that's by design. I did say they were not happy, right? That's by design. It is how it's supposed to work. If the cluster does not have majority of votes, it will take itself offline. Whether the primary is healthy, whether the primary or SQL Server or databases, whether there's something wrong, or regardless of whether it's perfectly healthy, the cluster will take itself offline as a side effect of it losing quorum. Oh, and by the way, the fact that the cluster relies on networking is what determines whether or not the cluster will decide to take itself offline. Again, they were not happy with that. And I keep hearing all of these descriptions of when an availability group went offline. A recent customer had everything on AWS. Same thing. They encountered a 4-hour outage. And I knew exactly why. The mere fact that they mentioned AWS, how most of the public cloud infrastructures recommend that you deploy your replicas across multiple availability zones in the way the networking is. I already knew that it is a networking issue, but of course, knowing is one thing. Digging into the event logs and understanding what really went on while this issue was happening would clarify things up. And we're just talking about the failure of a cluster here, right? We're not even talking about the fact that your primary is sending transaction log records to every secondary replica. That requires network connectivity. And so if your network administrators are not aware that this is what's going on, okay, they could be doing something that they've done forever, meaning this is part of their day-to-day. They've done this a couple of times, like for instance, upgrading switches. Our old switch is, we need to replace our old switch because it's out of warranty. It's out of mainstream support. We need to upgrade it. Not realizing that your failover cluster nodes are connected to that switch, and they're not aware. So they just do this, okay? Or pushing out a network firewall rule, not realizing that the firewall rule could potentially block failover cluster ports and availability group ports, the replica ports, that is. And then all of a sudden, your AG is not replicating, your failover cluster goes offline, all because the network does not work the way it's supposed to work. And you can't blame the network guys for that because they're just doing what they're supposed to be doing. It's just that they're not aware that your availability group depends so much on the network. Your failover clustering depends so much on the network. The way SQL Server replicates data across different replicas is dependent on the network. So latency and misconfiguration, if the network guys are not aware, the network admins are not aware, then that could potentially cause issues to your availability groups, which would take your entire cluster offline, taking the databases offline, and next thing you know, your always on is not on. Third thing is unexpected performance bottlenecks and issues. In the earlier iteration of always on available group, SQL Server 2012, Microsoft was clear when they told customers when it comes to synchronous commit replication mode, there is a performance hit because of this concept of a two-phase commit, where a transaction comes in on the primary has to wait for the secondary replica to write those transaction log records corresponding to that transaction on the secondary replica's LDF file. That is for the synchronous commit. And Microsoft was very clear. In the succeeding iterations, 2014, 2016, they've improved the performance of the secondary replica writing to the LDF file. They improved performance of the secondary replica, compressing the log records if you're using async, of course. The goal is to make sure that the performance on the primary behaves as if there was no availability, which is good, okay? Which is good. But you got to measure that before you even push or deploy your availability groups in production. You have to make sure that you're measuring, and it's a little bit challenging, of course, if you don't have performance metrics to base on. Meaning, if this is a brand new deployment, brand new database, brand new application, so there's no performance metrics. I mean, how would you know the performance profile of an app when it's a brand new app, right? If it's an old app where it was once a standalone instance, now the database is being added to an availability group, you kind of have at least an idea of the performance profile, meaning the CPU, memory, and I/O utilization based on, of course, assuming that you have a monitoring tool in place. But it's kind of difficult to guess when this is a brand new installation and you don't have anything yet. Okay? Keep in mind, again, with asynchronous commit replication mode, there is a performance hit because the secondary has to respond back to the primary before the transaction is considered to be committed from the point of view of the application. So you see a little bit of a delay. In fact, this is one of the things that a previous customer had an issue with. They were running a kind of like an emergency response system, like a 911 system. And a delay of 5 to 15 seconds spells the difference between life and death. That's how critical this system was. And they were starting to see a little bit of a performance issue, again, stretching from a couple milliseconds to 1 second, 5 seconds, all the way to 11 to 15 seconds. That's unacceptable. So they knew for a fact that this was a performance issue that they're encountering, so they started identifying the tables that need to be defragmented because of the indexing. So they started doing indexing, but they started to also realize that, hey, we cannot keep doing this because the index maintenance added more to the latency. And so they kind of have this compromise between when we're doing index maintenance throughout the day, not for the entire database, by the way, but for small portions of the database. While we're doing the index maintenance throughout the day, we will switch our replication mode from synchronous to asynchronous. After the index maintenance is done, we'll switch it back to synchronous, knowing full well that there are risks associated with switching from sync to async and back, potential data loss. But that is acceptable compared to somebody on the other end of the line on a call where there's an emergency and there might be real danger. Okay, so these are things that you have to really think about. And I'm not even referring to performance when it comes to turning on your secondary as a readable secondary. I've seen cases where normal workloads, nothing's changed, and all of a sudden there's a spike in CPU and I/O utilization on the primary. When we started investigating, we started seeing the amount of ghost records that have not been cleaned up is piling up. It's increasing to the point where the primary is now starting to have performance issues. Okay, as a side effect of turning your secondary replica into readable secondary replica, which also defeats the purpose because you're kind of thinking, wait, we'll offload the reporting workload from the primary to the secondary so that the secondary will take over some of the reporting workloads, but then it's causing the very thing that you did to offload read-only workloads from your primary moved into the secondary is now causing performance issues on the primary as a side effect of ghost records not being cleaned up in time. So a lot of these things are unexpected performance and bottlenecks issues. And again, I'm not even talking about the well-documented extra 14 bytes the minute that you turn your secondary replica as a readable secondary replica, where every row that you're reading off of your secondary replica will have an extra 14 bytes at the end of that row. Wait a second. That means my row is now wider, which means now my page is going to be full and fewer records can fit into the page because I'm widening my row, which means, oh, fewer rows means I have to add more page. So there's more page splits happening. There's more temp DB utilization. There's more storage requirements. As a side effect, if you're turning your secondary replica into a readable secondary replica. Okay? These are things that happen as a side effect of you implementing always on availability groups. And if you're not prepared for these, you might be surprised that all of a sudden things are not working the way you expect it to. Oh, and by the way, I'm not even talking about having your availability group replicas run in VMs where the physical host is oversubscribed, where the vNUMA is not properly configured. Again, I can spend an entire day just talking about the impacts of hypervisor and VMs not properly configured and causing unexpected performance issues on the VMs. SQL Server is feeling the pain, but the hypervisor's reporting and monitoring tells the VM admins everything looks good. Okay? And unless you're aware of these, unless you prepare for these, or even better, unless you've properly configured, implemented, deployed, and monitored the entire infrastructure, these issues, hidden dangers will creep up behind you and hit you like a ton of bricks and not realizing something went wrong. That's why, again, there's this common joke around always on implementation. It's almost on, sometimes on, or never on. And it's not the fault of the technology. The technology works the way it's expected to work. It's just that sometimes we are not aware as technology professionals that these are things that could potentially happen the minute that we implement the feature, we turn the feature on, and deploy it in production. Okay, so that's why you have to be ready for this. And the real key here is awareness and vigilance. It's not a set and forget thing where the wizard said, I need to do this, click, 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 next. We're off to the races. We now have an availability group. Let's add more databases into it. It does not end there. That's why proper awareness of what is going on, even things outside of SQL Server, like failover clustering, networking, storage, hypervisor, the way your hypervisor works, the way it is configured, having everybody on the team involved, your networking guys, your VM admins, your storage admins, in addition to, and the sysadmins, of course, in addition to the DBAs, they have to be involved, they have to be aware, so that every team doing what they're supposed to be doing, they're doing what they're supposed to be doing, does not step onto your existing always on available group implementation. Again, the last thing you want is for everything to be working fine, and then your sysadmin performed something that they've done ever since, and now it's causing issues to your availability. Or a network guy decides we're implementing this as a security compliance requirement, and next thing you know, their availability groups are no longer replicating data to the secondary replicas, and then all of a sudden cluster went offline. All of these things, you have to bring everybody in the picture and make them aware. So awareness is one thing, and two is vigilance. Vigilance. Newer features, newer versions will introduce new challenges. You got to keep yourself updated and be aware of what's going on. Monitoring, proactive administration, these are key to make sure that what you design to be a highly available solution, and of course, disaster recovery as well, the very thing that you designed to be highly available stays highly available. And the only way to do that is by making sure that you're proactively managing this. I love when people say, oh, it's a set and forget thing because we've done it properly in the design and implementation phase. We've done it properly. We've involved everyone on the team who needs to be aware of this. We deployed it in production. 6 months later, we forgot that we actually have it. Of course, they still implement and they still install cumulative updates, but it's not that they, a cumulative update gets released today and they'll roll it out tomorrow. No, they wait for like 6 months before they implement cumulative updates. But that is part of it where they would say, it's a set and forget thing. But you only get to that point where it's a set and forget thing if, number one, you properly designed and implemented and configured the entire infrastructure. Two, you're aware of these hidden dangers. And three, you're proactively managing the entire infrastructure, not just the SQL Server databases, not just the availability groups, but the entire ecosystem that helps SQL Server become highly available. All right, that is about it for this week's episode of the Practical SQL Server HA show. Tune in again next week for another episode. And if you need help with anything related to SQL Server high availability and disaster recovery, again, whether you're in that phase where you're designing a SQL Server high availability solution, you're thinking, we're not ready for this, but we're getting pushed down from upper management because this is now a regulatory requirement or a compliance requirement. We need to be as fast as we can possibly can without sacrificing quality and compromising on the proper implementation. Or you already have something in production, excuse me, and you're having issues. You don't know what those issues are. Okay. Use this link on the screen. This will direct you to my calendar page where you can pick and choose a time that works for you. Go through my calendar, see a time that works for you, and we are going to do what I call a strategy session where we're going to get clear on two things. One, we'll get clear on where you are at. Are you in the design phase? Are you in the implementation phase? Or excuse me, you're in the post-production? Yeah, that kind of sounds like a media thing, right? You've cut over to production and now you're struggling with managing it. We'll get clear on what your challenges are, and the second part of it is we'll come up with a step-by-step game plan on making sure that we're addressing those issues and those challenges. Okay, so use that link on the screen, schedule a strategy session, and I'll be more than happy to help you in any way I can. All right, that is about it for this week's episode of the Practical SQL Server HA show. Tune in again next week for another episode. Again, thank you for people who have been sending me DMs, emails, and commenting on what potential topic should I cover in my next episode, right? And with that, thanks for joining in. I'll see you again next time.